Thank you, Mr. Kremer, for the short introduction. I also want to warmly welcome you here in the Bavarian Embassy in Brussels. So last time I was here in Brussels, my son studied, and there was a nice Nikolaus festival during the pandemic time. So it doesn't seem to matter really. So, but what matters is the tire wear. We have heard that although Mr. Bosman has mentioned the paints, we should concern about the paints and also the pellets. We have here two presentations about tires, and Romana and me, we contacted before so that we don't borrow you so much. We make a little bit different presentation. She spoke more or less about the new products which were found in the tires, and I want to talk about the reduction and also maybe starting with an old table which was the initiation of the Plastic and the Environment research campaign. So we have here the table from the Fraunhofer Umsicht. It does not work. So. No. Oh, it doesn't matter. Fraunhofer Umsicht, and there they detected at that time in Germany, tire wear is the highest emission of microplastic. But if you see here, also 0.4 is the pellet losses. Maybe the calculation was at that time a little bit wrong, I don't know. And also we cared for plastic sport fields. It was a little bit different. We made investigations in Sweden because Sweden in that time played better football than the Germans, so because they have all plastic soccer fields, and it's not applied in Germany. And also you can see here abrasion from shoes. They calculated with 4 shoes per inhabitant. Yeah? Look at your shoe cupboard. So my one is from 2019, but this has made already a lot of abrasion in that time. And also we have the textiles mentioned here. The textiles, I don't agree with the colleagues. I would say leave the washing machines as they are. We have a good sink. It's the wastewater treatment plant. I will show in the last slide, but we can discuss it. It depends on how we use the sludge in here. So what are the pathways of microplastic in general into the environment? So we have the traffic infrastructure and our household. The traffic, there we have the direct runoff. We talked about the soil. We have rainwater sewers, and if we have a separate system, or we have the combined sewer systems when we have an overflow if we have heavy rain. So this is a huge amount, but it only appears temporarily. Then we have the sewer itself with all our household products going to the wastewater treatment plants. And then at first, no one knows how to make a proper sampling. We discussed the sampling in the soil, but it was not known. And still now, we have no ISO or European, European standard for that, so sampling. And we thought about it in our project. We used the brush. Of course, a plastic-free brush, yeah? You can see here. And we compared it also with a vacuum cleaner. And the vacuum cleaner, there's still, if you remove the dust and particles afterwards, it's still something in the vacuum cleaner, so we decided for the brush. And also we developed some captures with filter system, filter cascades. This is also another method. Then looking at the pre-treatment of samples. So we have Mrs. Altmann here sitting together with her, or mainly she developed this sample arriving in the lab, freezing, freeze dryer, weighing, milling, and afterwards we can think about how to analyze the microplastic. We can choose on the one hand the particles, look at the particle size, calculating the particles, and then we have the length and the diameter of the particles, or we use thermoanalytic methods. There we can calculate or analyze the weight of the microplastic, which is normally used also for other substances, of all our substances. So we decided on the second one. So then we have to look at the tire wear emission from the stormwater. Of course, we have the tires, but the tires are not alone in the environment. We have also the road. And so always we have tire wear road particles. We know, the range of the size up to 350 micrometers, 5 to 300 micrometers, and they may look like that. Then how do they appear? It's on the one hand, of course, we discussed it already, the tire characteristics and the composition of the tire, of course. This is one reason, but also the road surface and the vehicle. Passenger car, truck, heavy passenger car, these famous SUV cars, we don't like them anymore, I hope. And so also the behavior of the driver, acceleration, stop, and the traffic. So one older study we detected in our departments, it's from 1997, but also from the Technical University. They looked at the engine power and the abrasion of the tires. And you can see, as higher the engine power is, as higher we have abrasion. So this is only one criteria. And then we decided to look at the roads. What happened? Maybe a traffic light. We detected so-called hotspots in a city traffic, and that's a traffic light where we start and stop. Also, we had a curve, you can see the curve, and a slope, a roundabout. We also made measurements as comparison at a graveyard. And I ordered to have this bridge where I go with my bicycle. Whether there is also maybe we can detect tire wear. So, and we had the highest traffic-driven highway in Germany, more than 100,000 cars a day, and there is a retention soil filter where we also took measurement from this retention soil filter, but in the end, we found nothing. No particles in the end of the retention soil. Okay, we went to in the traffic business, we measured the speed. We had to be careful that no one says we are for speed control, and the length of the traffic, so you can see here a car, this is a bicycle, and maybe here also you will find a truck. In the end, we found out with our sample taking that most of the road dust can we find at the sidewalk, at the side of the road, due to the wind of the cars and so on. The most pollution is at the side. And then we also looked afterwards, when we have developed the measurement systems, this styrene butadiene rubber as a marker for the tires. In former times they used zinc, but zinc is also from other emissions. So, and there we found the highest SBR marker in this curve and at the traffic light. By the way, at both sides we had around 800 cars per day. So just the same amount, we took the same road. And in the end, we calculated here for the European Union together in a literature study, how is the distribution, and there we found out in urban, 70% of the tire wear goes into the surface water and 2.8 in the soil, and in rural areas and also at the highways, the larger fraction goes into the soil, which we have discussed already before. The air, more or less, you see here, 5%, it's estimated, it's really estimated. And we came at least to the same values which we had from Romana, 450,000 tons in Europe, and a little bit more, so we have more traffic in Germany as in average in Europe. So what to do? How can we reduce the emission? Yeah, we can make hotspots, we can improve the road cleaning, we can build up intelligent networks and modeling measures. Okay, then I have enough time. So first thing, we looked at was hotspots. Maybe filters in the gullies, installing filters in the gullies, and we have a project on that with modular filters. So not only conventional filters, which have only one focus, so we can add maybe a mesh in it, and we can also retention spice, and we found out some of the particles are magnetic. We can also implement a magnet. So this is which we can test, and we have a test booth in our hall. We can see here we can integrate the filter in this gully, and there we can put in material. So there are standard materials in Germany, but we don't like these standard materials. We took real road dust and filtered the road dust and mixed it again. You can see here on the upper side. Also, we took other pollutants into the road dust, like cigarettes we find also on the road. And yeah, actually we won't find mask anymore. And also real tire wear. Yeah? So the other thing is to look at the road cleaning. So usually a road cleaning truck only is designed on the dust it puts out into the air. No one looked at the efficiency of road cleaning. So we did it in a hall and also in practice, and you can see nearly 90% efficient. So they are really efficient, but they should go out. That's our idea. Intelligent road cleaning. They should go out. Measurement of the weather. When it's starting to rain, or before it's starting to rain, they should clean the roads so that there are no emissions in the waters. So also, after our study, we detected there are different tire compositions. We know it from the market. And so I took the names out of this comparison, but you can see this is carried out by the German Automobile Club, and it's a huge difference, 95 gram per kilometers up to 136. So it's the same curse they drove, maybe 2,000, or we are in Bavaria, around Munich, 3,000 kilometers around Munich, and then they measured the weight. So it is possible to make different compositions of tires. So these are our measures. These are the suggested measures which we have in our study, where also Mr. Bosmans is responsible for. We work for him also, labeling the tire wear emission, alternative materials, extended lifetime, and the problem is also for that good test methods and emission limiting values. So then also we can look at the cars, at the vehicles. There we would recommend artificial intelligence, that you are not responsible for it. My car always brakes very strong, so it's not good. And also there are some new ideas, capture devices for the abrasion of the pellets and others. And in the end, also we can look at the roads. Maybe porous asphaltus could be a solution. Afterwards, cleaning the asphaltus. And the other mobility. I came with a truck, with a train yesterday. It's not a real sure transport device, but we can also take our bicycle. There were many bicyclists in the morning when I walked here. So, and our favorite is this road cleaning. We will have still a leaf over of abrasion, so that we have to remove this, and then we have an intelligent road cleaning, or also this cleaning in the hotspots. Yes, a long talk about wastewater. We have also had another project in the PIDO initiative, where we looked at the wastewater treatment plants. And you can see here, we have a very good efficiency at the wastewater treatment plant. So about 99% removal of microplastic in the conventional one. So all the textile fibers from the washing machine end up there. So it should be no problem. Even if we build up filters in the end for other purposes, then we have more than 99%. But we have to discuss where the sludge ends. Do we use it for agriculture? Then we have it in the soil and in our products. And do we burn it, as the Germans want to do it in up to 2029? Then it's no problem. So I made up this list for the discussion, but I don't want to go into the details. I mentioned all the suggestions for the reduction of tire wear. Thank you very much.